Alright, so you want to understand how a GPU actually works, but all the tech darks read like a boring legal contract. Welcome to Tiny GPU, the project that turns "how does this magic box work" into "oh, that actually makes sense." Think about it. Your GPU is basically a celebrity. Welcome to our channel. You know what it does. Makes your games beautiful and your AI models smart. But you have no clue what happens backstage. CPUs. Sure, there's tons of open source designs. GPUs. Nah. The big guys keep those blueprints locked in a vault. So I built Tiny GPU. It's like a GPU, stripped down to its underwear. No fancy ray tracing cores, no mysterious tensor units, just the bare essentials you need to understand how thousands of threads party together in parallel. Here's the vibe. Tiny GPU is built to run one kernel at a time. That's a small program. You load the code, load the data, tell it how many threads to launch, and yell "Go." Inside, you've got a dispatcher, the ultimate party planner. It takes your massive guest list of threads and groups them into manageable blocks, then sends each block to a compute core. Each core is like a mini CPU with multiple personalities. For every thread, it's got a dedicated ALU for math, a load store unit for memory, and its own set of registers. It's like giving every thread its own tiny brain and hands. But here's the secret sauce. 3 of those registers are read-only, holding each thread's block ID and thread ID. This is how the same piece of code, like add these 2 numbers, knows which numbers to add, depending on which thread it is. That's SIMD in a nutshell. Same instruction, different data. The instruction set is tiny, only 11 commands. Think ADD, sub, jump, load, store, the basics. It's assembly language on a diet. And get this, it actually works. We've got full simulation for matrix addition and multiplication. You can watch every thread, every cycle, every register change. It's like having an X-ray for parallel computation. Now, obviously, real GPUs are way more complex. They've got layers of cache, memory coalescing, warp scheduling, and they handle branch divergence, where threads in the same group can't agree on what to do next. Tiny GPU keeps it simple on purpose, so you learn the rules before you break them. So if you're a dev who's tired of CUDA feeling like magic, or a gamer curious why your RTX 4090 needs its own power plant, check out Tiny GPU. It's the explainer you didn't know you needed for the hardware you definitely use. Like, share, and subscribe.